Everyone right now is talking about vibe coding, but in truth, vibe coding usually produces a bunch of junk. And so in this video, I'm going to be showing you the cons of vibe coding and the inherent flaws with it and the tremendous amount of vulnerabilities produced from the stuff it is generating. So by the end of this video, you understand what vibe coding truly is, why it's not that great, and ultimately how to navigate vibe coding's current form. So let's start off with the origins of vibe coding. Now, vibe coding originally came from Andre Karpathy, former director of AI at Tesla and founding member of OpenAI. Now, it is pretty common knowledge that he is not at OpenAI anymore. He went on to do other ventures, but it signifies a fundamental shift in how we create software. I mean, no other time in history is someone able to prompt an AI to make me a landing page, go away from the computer and maybe come back and have a full functional landing page pretty much built out for them. And kind of the nuance of vibe coding is that it's achieving results with a zero understanding of underlying code from the user. And so there's kind of two roads, and that leads us to a critical destination where on the one hand we have vibe coding, so there's no understanding of code. AI does 100% of the work. There's no review or vetting, basically with the mentality of it mostly works. Maybe if you've chatted with your peers or even yourself, it's kind of just like, it looks good, let's ship it and move on to another feature or something else. And then we have the AI assisted programming, which is completely different, right? So we have a programmer who understands code. AI accelerates development, kind of like steroids. You can kind of think of it like that. And then there's a human review and validation point, which is super important for the reasons I'm going to explain here shortly. And there's due diligence on security. And so the difference isn't about using AI. Both camps are using AI, but it's about maintaining control and understanding of what's being built. And so it mitigates a lot of this vibe coding junk from the vibe coding camp. And so I think it's important to understand why AI code is dangerous, and what's kind of behind you developing these tools. Well, number one, there's a hallucination problem. So if you understand AI, you understand that it's plausible code, not correct code. So it predicts what sounds right rather than what actually works securely. And we'll talk about this further on because this is a massive problem with vibe coding. A lot of you think that you're just putting together a flawless app that can go to market and take a bunch of user data. That's not the case. The case is it's plausible code, not correct code. There's inherently a ton of flaws with what it is generating. And then we have runaway loops, which are never fun. AI agents ignore instructions. Maybe you've played around with some of these models and it doesn't really seem like it's listening. This is kind of what we're talking about. And so they delete data, and I'll show you an example of AI actually deleting data here in a second, and it spirals out of control. And so then obviously we have a knowledge decay aspect of things where we're losing skilled developers, right? And this causes a massive problem because we're not going to have individuals who can identify and fix problems. And obviously this threatens our ability to maintain tomorrow's systems. And so it's important to understand what happens when AI is hallucinating and why it takes place. Well, LLMs predict most likely responses, not accurate ones. And so this is very important because of the weighting of the model, the neural networks. It's kind of this maze of things taking place, and we really don't know, like I've said before, how it comes out with this output, but it's a most likely response. It's a predictable response, not an accurate one, okay? And in terms, maybe you do say, well, it is correct with this and this. It's because it's predicting that based on what it's kind of learned, I guess you could say. And so most of this stuff is trained on public code. And if you look at public code, 95% of it is poor quality and not just great stuff we should be probably iterating or creating more of, right? And then there are massive security flaws baked in from the start due to those reasons. And so it is rewarded for confidence even when wrong. And you can even see that when you maybe prompt these models. It's going to give you a very confident answer. Yes, it's just completely correct. There's no flaws. It adheres to X, Y, and Z compliance. And you think, great, but it's not the case. All right, so think of it this way. Guessing a birthday has a 1 in 365 chance of being right. Saying I don't know, and it guarantees 0 points. And there's really only a few specific instances where it's going to say I don't know or I can't do that. And vibe coding most likely is not one of them. And so that leads us to the cost of AI slop. And so these are 3 examples. Let's break them down. Number 1, if you recall the T dating app, well, they had a massive breach. So 72,000 users' photos stolen to an improperly secured AI generated database. So personal data exposed because AI created vulnerabilities. vulnerabilities from the start. There was no human there to understand what it was creating and the vulnerabilities associated with that. And then we even have Microsoft itself had a Copilot leak. So it exposed a ton of confidential internet data from Google, IBM, PayPal, and Microsoft itself. And then we have Replit, which maybe you are using. It had a database catastrophe. So get this, on July 18th, AI deleted entire production databases of 1,200 customers. Then, more importantly, it attempted to cover up the mistake by fabricating test results. And so you can see, based off of these things, we can't fully rely on AI just yet, because even Microsoft and Replit are having issues doing that. And so kind of in truth, if we look at the data, a concerning 45% of AI generated code is found to contain massive vulnerabilities. And so while syntax errors decrease, critical architectural flaws surge by an alarming 300%. And you don't want the architecture aspect to be flawed. And we can see this feedback loop take place because developers now write 3 to 4x more code with AI, but submit fewer larger pull requests, making comprehensive review increasingly more difficult because there's just so much more of it, and that's just going to lead to more human mistakes and more vulnerabilities. And so what's taking place is kind of this death spiral. And so AI is going to generate buggy code from your prompt that you're going to give it. You're going to say, hey, create me an app that does X. It's going to generate a bunch of buggy code. That code gets published online, right? You're going to put that onto the internet, and then future models train on this flawed code, which is going to have more of a negative feedback loop. And then the next generation produces worse code because the foundation it was pulling from is not great in the first place. And then the cycle repeats itself, and the system ultimately breaks, or it's just a bunch of junk. And so from my personal observation, I've been playing around with these tools for a very long time. Even when using AI tools, I noticed this circular pattern. Okay, so it references its own previous suggestions, which again are probably not great from the start, and then it compounds errors and spirals away from the original intent. And once it starts spiraling away, it's very hard to kind of reel it back in and pull it back in to get it back on the road, so to speak. And so when you're using these models, you have to be very careful of this taking place, and you have to become aware of it. And so here's really the fundamental flaw. So LLMs predict tokens, which essentially are just words. They do not understand goals. So when you're basically creating these models, you're going to feed it a bunch of information, and those are essentially the tokens, right? So it's a prediction machine. Cat in the, and it's going to say hat, right? Most likely, because that's just what it's been fed. Okay, but it's not understanding the goals. And an example is don't touch red button. Well, that still contains touch red button. And so we have this massive disconnect because it's going to predict don't touch red button, but it still contains 3 key important words that change the trajectory of where the AI is going to head completely. And so it's important to understand that. And then essentially it's trained on good and bad examples. So it's pulling from kind of everywhere. And it's probability based, not obedience based, as you can probably tell if you use these models. And so there's a classic example. It's a great video. Claude, what they tried to do is they tried to actually get AI to kind of manage a little shop they had at their headquarters, I believe. Video of that will be down below. And so essentially what the AI did, it hallucinated fake employees. I mean, the Claude team didn't even say create employees or any of this stuff. It just automatically started creating employees at random. Very weird. And then it threatened to fire real staff that worked there, which is crazy. It created a fake Venmo account, and it hallucinated visiting Homer Simpson's house. And you can see, like, that is completely wild. That makes no sense at all. And then it started emailing security about physical delivery impossibilities. And so you can see how we can't fully rely on AI just yet. And so I like to think of vibe coding as a relay race. And so if you recall, you'd carry the baton, that stick, and you have people, your team members, around the track. And so with vibe coding, sure, maybe you can get to the first person or second person or even the third person quite quickly. But if you just kind of vibe code the entire app, well, you're not going to finish the race, or you're not, like, it's going to be a completely different race, right? Kind of going out of the bounds of the track, if you want to say. And what a lot of people do is that, sure, they can quicken the pace of the first, second, and third person, but then the fourth and fifth person is usually the developer carrying the weight of the team on their back. And so as we can see, we can't fully trust these AI systems just yet because it's a lot of junk and a lot of fake stuff tends to happen. And so the massive question is, who will fix tomorrow's code? And so what we're seeing right now is that there's a junior skills gap. And so what's taking place is that junior developers right now are no longer getting grunt work. And so unfortunately, if I can't get that classic grunt work, I can't really learn the fundamentals that well. So what's also taking place are that senior engineers who use AI instead of mentoring the younger generation. As we can see with the current economy, a lot of these jobs are just being replaced by AI. And so in 5 to 10 years, we're going to see a missing generation where I'm not too sure who is going to debug deeply, write secure code, and understand system failures when mid-level expertise vanishes, which is a massive issue. And then further down in the future, we're just going to have a bunch of technical debt, just a bunch of junk, because we're going to have buggy, insecure code everywhere with no one who knows how to fix it. And so the ultimate question is, how do we navigate the vibe coding world in its current form? And so you can start by learning coding fundamentals. And it's important to note, it's not to code. So you're going to start seeing this managerial form take place where you start stepping in as the manager. That's essentially what you're going to do. So you're not trying to code, you're just understanding the fundamentals so that you can vet quality, right? So you can take basic courses in Python and JavaScript, understand common security vulnerabilities, and learn to read code reviews. That's kind of your first step. And so the next step would be to hire CS experts or just partner with them. So you can hire experienced developers as advisors. Again, this managerial aspect of things. You can have code audited by security professionals, which is massive, and you can use code review services for critical features. And so number 3, and most importantly, establish quality checkpoints, which is super important with the vibe coding era currently. And so you want to require human review of all generated code, even if you just are using Opus 4.5 yourself. It becomes even more important to implement automated security scanning systems and maintain backup and rollback procedures, just because if AI does misstep, you have some of that already saved, or you can just easily go back to. And so as you can tell, vibe coding is nowhere where it needs to be just yet. And as always, my friends, I will see you next time.